We're going to look at volume for cylinders and cones. This is unit 8.3. And the reason why we're combining cylinders and cones is because they both have circles as bases. So the formulas are pretty similar. So you could read through this section, and we're going to look at a couple of the examples. We're going to look at example 2 for a cylinder. You can see the formulas over to the right, up here on the right side. The formula will also be given to you on the regions and on the tests. So let's get right into it. So for example 2, again, we're going to use the formula pi r squared h. I will also express the answer exactly and to the nearest tenth. So the first thing we need is the radius and the height. And in this case, the radius is going to be 3 because this 6 represents the diameter. So the radius again is halfway across the circle. And our height is going to be 4. That number is connecting the two circle bases. So the first way we're going to express the answer is going to be in terms of pi, which would be exact. So the first answer would be 36 pi, and you would just put in the 3 squared times 4 in the calculator. If you want to get the the answer rounded to the nearest tenth, what you would have to do after you turn it on is you would type in pi by hitting second and then the caret symbol. And then you could type in the expression, 3 squared and then 4. And this will be the answer to the nearest tenth. So exactly it's 36 pi, but rounded it's going to be 113.1. In this case it's centimeters cubed. And that would be centimeters cubed for each of these because we're talking about in terms of volume. So that one's example 2. And then again, it's a cylinder. Now I'm going to erase this. We're going to go to the back of this page and we'll look at a cone question. And we're going to look at example 3 on the cone section. And up here it'll show you the volume for the cone, which is pretty similar to the volume for the cylinder. It says right here it's 1/3, because 3 cones, if you fill them, would fill up 1 cylinder with that same radius and height. So we're going to look at example 3 together. And you'll notice that with example 3, we have a radius. They say it's 5. But the height we don't know yet. And we're going to use this right triangle that was created with the cone to help us find that height. So we're going to use Pythagorean Theorem for that, to find that third side. And that would be how you would set it up, because 13 is your hypotenuse. And you square both sides, subtract the 25 over, and then take the square root. And you're going to get the height is 12. So we're going to be using 12 for our height. So I'm going to go ahead right now again and write down my formula. And because it's a cone, it's got the 1/3 with it. The next thing I'm going to show is my substitution. Pi, and we have 5 squared and 12. Now I'm going to use the calculator, and again I'm going to express my answer 2 ways. I'm going to express it in terms of pi and then to the nearest tenth. So for the first one in terms of pi, I'll start by putting in the 1 divided by 3 for 1/3. And I'll skip over the pi, put the 5 squared, and then the 12. And then this is going to be our answer in terms of pi. So an exact answer in terms of pi would be 100 pi, and then it's centimeters cubed. Now, if I want to express it to the nearest tenth, again, I could keep this same calculation in. I just got to make sure I multiply by pi, so I'm going to do second, and then the caret symbol. I can throw that at the end. And then it'll give me an answer to the nearest tenth of 314.2 centimeters cubed. So, make sure when you're doing the examples for these that you express your answer, and look how the answer is expressed. Sometimes it could be to the nearest tenth, kind of like the second answer, or you might see E or exact answer, which would be in terms of pi. And then also keep in mind, you want to make sure you got your radius and height. And if you don't have one of those, maybe you're going to have to use Pythagorean Theorem, and maybe you may have to use sine, cosine, or tangent if you have a degree.